Hello, hello, hello. Welcome to Coder Radio. I've got a great show for you today. I've got Frank from MongoDB. He's frankly schooling us all a bit on what's going on with Mongo. Not an area I cover much. I'm pretty deep into the Postgres, now PG Lake world. This is super interesting. For those who don't know, Mongo is a document store database rather than a traditional SQL database. We kind of go into that. This is a pretty good primer for anyone who's not familiar with it. And also, frankly, some things I didn't know Mongo could do. The last time I looked at it was, I was still living up north. And it was kind of it was very new, and it was the hotness that people were kind of saying, oh, you'll never have to do SQL again. I don't know if it's an old video, but there's an extra normal, one of those teddy bear voiceover videos about MongoDB being web scale that was kind of going around. There's also one of Rails. So this is about the time, right? Like Rails was super big. If you were up in that startup-y New York City ecosystem, those were too widely used, but also kind of like jokingly mocked things. I think folks who know is like when Node became popular, Mongo really hooked into that. A lot of people doing like Express with Mongo, stuff like that. So really interesting chat. We've got a couple more like this coming up where it's going to be a pretty good mix over the next few weeks of startups and either super enterprise people, but also platform vendors, right? And open source project maintainers. Also got some slight changes for the new year that I think you are all going to enjoy. So yeah, it should be fun. As always, check out the Discord, check out that hiring channel, check out alice.dev. I'm sure there'll be an ad cut into the show. And I will talk to you later. Enjoy the show.
Are you still running your business on slow, manual spreadsheets? Your most critical data is trapped. Alice is the automated bridge that sets it free. Connect your legacy sources in minutes. Use Simple SQL to transform your data and send it directly to modern tools like Power BI. Alice automates the work so you can automate your business. Stop guessing. Finally, trust your numbers. Get started at alice.dev.
Hello, folks. I'm here with Frank Pachot, developer relations over at MongoDB. Big data, lots of data. Love it. How are you doing, Frank?
Hi, Michael. Yeah, doing well.
Good. It's great to have you. So for those who maybe aren't super familiar, what is MongoDB at a high level?
So MongoDB is a database like many products that have DB at the end, but it's a database that is a bit different from other databases. It started with NoSQL, and maybe I can explain a bit more this move from SQL databases to NoSQL. But today it's really a database that has more features than many NoSQL databases, but still not the same as an SQL database when you use it. So yeah, maybe I can just explain quickly, because I've been working with databases for 30 years, so I've seen this evolution of databases. And I started with relational databases, where the idea was to normalize the data, having a central database for the whole enterprise. When I started with databases, the idea was that we were doing data modeling for the data without knowing which applications will use it. And this was working well until the client server and object-oriented languages, where it has shifted from a data-centric point of view to an application-centric point of view. And then those applications had to map the object model from the application to the relational model with an ORM like Hibernate, but that added a lot of complexity. And also at the same time, the big monolithic applications have been split to multiple services or microservices. So developers develop differently their application, their backend that connects to the database. And basically, this is where NoSQL started, not trying to do this normalization that SQL was doing, but more doing the persistence for the application with objects or with documents that map the objects. And MongoDB started like that and became very popular. So it also added later more features like transactions, the things that were not in the other NoSQL databases.
So if I'm looking at data out of Mongo, what am I seeing? I'm assuming it's not like a regular SQL table representation. Is it like a JSON structure or a document structure?
Yeah, exactly. The SQL databases are based on tabular data. So the idea is that even if you have complex data, because data is always complex, there are many details, the relational databases tried to split that, normalize that to multiple tabular data. And for example, when you have an order entry application in a relational database, you have a table where you have the customer information, a table where you have the order header, a table where you have the products that are in the order. So many tabular tables, where the idea of document databases like MongoDB is more storing documents that really look like the business document. For example, if you take orders in paper because computers are down, you will not put in multiple pieces of paper the different part about the customer address, about the product, about the quantity. You will have all that in one paper where you have multiple lines for the product, where you have a header with the customer. And this is how data looks like in MongoDB, JSON, where you can have objects, sub-objects, arrays for one-to-many relationships without trying to split that to multiple structure to make it easier to map this model to the object model of the application and to what the user see. For example, when a user is doing a transaction like taking an order in a relational database, you say to the database, I start a transaction, and then here is the order header, here is the customer information, here are the lines. So you have multiple statements, and at the end you say commit. Where with MongoDB, you can also do that, but you try to have everything in a single document. Like, here is my order, and this is what must be stored together because I will access to the whole order later.
Okay. So let me see. On a high level, I would assume in all of these documents are mutable then, right? You can, for instance, can I have an order that has 3 customers or 2 outside vendors instead of just one? And I don't have to formalize that in the
Yeah,
schema?
that's a good point. The flexibility of the schema, you can start inserting your data without defining the general shape before. And this is how applications start. For example, you can start like, I think that each customer has only one email because you don't need more. And if at some point you have to store multiple emails because you want a backup email or whatever, you can just store the new customers with 2 emails. And then what was a scalar value in a field is now an array. If you want to do that in a relational database, this is a big migration because when something comes from a one-to-one to a one-to-many, you have to split it to multiple tables. So there is more rigidity in a SQL database with a purpose, because the purpose is to normalize the data for many applications. But when you know the application, you can have a model that just takes what's come from the application.
So I would imagine then the concept of joins, right? A join table in, let's say, Postgres, that's not a thing in Mongo at all. Or am I incorrect?
We try to be more precise. You always have joins because you don't want to store everything together. But the idea is that you avoid the joins for the things that you access often together. For example, order and order items, you don't want to join because they always come together. An order item makes sense only in an order. But this is possible only because with MongoDB, you build your database for a specific application or a specific domain. So if you are in the order entry domain, for example, as the example I took, the order is always one single thing. But if you are in a different domain like marketing or sales analysis, maybe they don't care about the order, they just care about the order items and the products, and they may model that differently. With a normalized database, one schema should be able to be used by all applications in the enterprise without knowing what are the applications are doing. And this is why there are things like joins that you do when you read. But with a document model, the model really fits the business domain. And then you know how you access it, and then you can shape it closer to the domain. And then you avoid those joins, which help for many things. For example, for scalability, if you join multiple tables and you want to distribute that to multiple servers because the data grows, or you want more elasticity, then you may have joins between multiple servers and you will pay the latency. If you have a data model where you know that your order is already pre-joined, stored pre-joined, then you don't have those surprises of additional latency later.
Right, because it has to do less hops from table to table because, well, it's a whole different model, is what you're saying, effectively. Like
Yeah.
the whole idea of going up front and normalizing my schema, just I don't even really do that.
And it's also less complexity because the problem with joins is not the join itself, but if you have a query that joins, let's say, 5 or 10 tables, then you write a complex query or you use an ORM that must be tuned also to know what must be fetched together or later. But also for the database, for the relational database, it's difficult to estimate the best execution plan for a join because you have to start by one table and then maybe filter a bit and then join and then maybe filter more. So the query planner, the optimizer in the database, has to estimate where it's better to start. And with two tables, it can be easy to estimate, but the more table you join, the less the estimations are accurate. So the complexity makes it slow, not because it's slow itself, but just because it's prone to bad execution plan and something that can take minutes instead of seconds, for example.
So, I think most of the folks listening are used to traditional SQL databases, right? Postgres, MySQL, MariaDB, whatever, right? Insert your flavor of choice. What is the kind of key conceptual change in their thinking they need to make if they're approaching Mongo?
That's a very good question, and that's also what I try. There are some old messages from NoSQL databases that were based on the structure of the data, where people were saying, if you have a lot of relationship, then use a relational database. If you have time series, use time series database, etc. Today, Postgres or MongoDB are general purpose database. You can do a lot with them. You can do time series with both. You can do OLTP with both. It's more how developers want to build their software. For example, if it's still the kind of development where you have one central database for multiple applications, if you start a database where you don't know all the applications that will access, still good to use a SQL database because it is normalized. So you can start without knowing how it will be accessed. But if you start like today, developers doing domain-driven design, they start with a data model before the database because they start with an application that has an object model in the application. And when they go to the database, they already have a good idea of the application that will access to it. They will have a good idea of the cardinalities, the number of rows or documents that go in the database. And then they can have something that fits better with a document database. So when there is this choice, beyond the choice where the syntax can be different, you may have different things to learn. It's more like if you don't know exactly your use cases, then it's safer to go to a relational database. It will be more work to map that later to the application, but at least you can. where if you already know what your application will be doing, you will just go faster with a document database. You can still normalize even if you have a single microservice, but it's more complexity that you don't need. So if you build a microservice or a set of microservices that will share the database, then it's probably easier to go with a document database where you can start quickly, just store your object and iterate. If you have to add new attributes for the next release, they will just go to new document and you don't have to run a big migration script on the database.
It makes a ton of sense, right? So I guess my winding up here is I know a lot of the folks, myself included, listening are using ORMs. You mentioned them in passing before. SQL Alchemy in Python, Active Record in Rails, I think Entity Framework on the .NET side. How much support of those, not specifically those, but of popular ORMs does Mongo have, or is that even the right way to think about this?
Yeah, it's the right way. The idea is that you don't need an ORM first.
Okay.
Or at least not as complex as those one, because they make life easier for the developers, because without an ORM, you have to maintain two data models. And you don't want to maintain two data models if you, except if it's very static and you don't add new features. So with an ORM, you can iterate on the application model and then generate migration scripts to the database. But the problem is that the ORM adds an abstraction where the developer doesn't know exactly what will run in the database. And usually it can generate bad queries. I've been working as a DBA on relational databases, and a lot of DBAs complain that ORMs are generating bad queries.
Right, slow. Mm-hmm.
Yeah, which is true just because it can be tuned, and the ORMs that you have mentioned can be tuned, but it's just additional work, and usually the developers have always many features to release and not time to look at the performance of that. So removing the ORM, or at least the complexity of the ORM, makes it easier. But still, you can use ORM like, for example, just you have your application with Spring Data, and you can just use document annotation instead of entity and relationship annotation. It's like an ORM, but it's much easier because it's not a mapping. It's not the R in ORM. It's not mapping to relational. It's mapping object to document, which is very similar. So it makes it easier. But also very recently, MongoDB has released an extension for Hibernate. So Hibernate is an ORM, was made for relational databases, but MongoDB has released an extension to use it on MongoDB just to make it easier. So of course, you will not have the complexity, but still you will be able to map embedded objects. So those objects where, for example, order and order items are embedded in it. But you will be also, it's just in preview now, but you will be able also to map joins between collections which are not like SQL joins, but still one collection referencing another. For example, maybe in your order collection, in your order documents, you will have some information about the customer, but still you will not put all information about the customer. So you will have a reference to the customer ID, which is very similar to a foreign key. And with this extension, it will be able to fetch the order document, the customer document from this. So it's still possible to use ORMs. The goal is to avoid having to tune the queries generated by the ORM because of the mismatch between the object model and the relational model.
That makes a ton of sense, right? So if you can avoid the extra complexity, that seems like a time savings to me.
Yeah, that's exactly the goal, and you can do that when you have a domain model in the application. If it's a data-centric development where you have one monolithic database, you will need this ORM. But usually you do on the other way. You evolve the schema on the database, and then you push that to the application. But today, most of development starts with the application, and this is where storing data's document is make life easier.
Makes sense to me. So I always end with one question, and it's a little silly. So what is one tool that you absolutely love, you can't live without? Now, it doesn't have to be a data tool, and it can't be something from Mongo. It has to be something you're not employed by, you didn't create yourself. We've had people come on and say, the last guy I talked to yesterday said that his electric bike was his favorite tool. So it could be anything.
So I don't know if we can call that a tool, but for me it's Linux. Just because all the troubleshooting tools that are available on Linux, I love to understand how it works. And Mongo is open source, so you can look at the source, but reading the C code is not very easy. But with Linux, you can trace what happens. And I always use that even for proprietary software. For example, on Oracle, where you don't have the source, you can still use Linux tools like strace to see the system calls or even a debugger on a software that is fully proprietary like Oracle. You can still attach a debugger and see the calls to the C functions and understand how it works even without having the source. So yeah, I will say Linux, yeah.
That's a great choice. I think most of us basically live in Linux all the time, right? So it's it's home.
Yeah, exactly. And also, I use also a Linux tool for my presentation. I use Tmux to set the window panes, and I use also a VI macros to send keys to Tmux when I present, just to run my demos faster. So yeah, everything is on Linux.
Wow. So you're running it on the desktop as well?
Yeah.
What distro, if you don't mind?
Oh no, sorry. No, I'm on Mac, but Linux is also there, and even on Windows, you have also Linux. You have Linux everywhere.
It's everywhere. It lives everywhere. That's right. All right. Well, Frank, thank you for coming on.
Thank you very much.
Have a great day, man. Well, I hope to come up to a Mongo event soon. I know there was. I think once a year there is one in New York, which is only a couple hours from me.
Yeah, the big one in New York. But yeah, yep. I'm based in Europe, so I go more to events in Europe, but sometimes in US also. Yeah.
Sounds good. Talk to you soon, Frank.